Okay, next keynote is from Annette Hafner, and she is an architect and professor of resource efficient construction at Ruhr-Bochum University in Germany. She and her research team have been publishing about carbon footprint assessment, urban material flows, wood construction, and circular economy of buildings. Recently, Professor Hafner has been analyzing all known technology approaches for storing carbon in the built environment. She collaborates with a wide team of international researchers, including Aalto University of Finland. Professor Hafner, we welcome you warmly to Helsinki. So, thank you.
Thank you. So, from my side, a warm welcome to you, all of you. What I want to show you today is kind of from a broad view. Holger was telling you about going back to how to operationalize that in the built environment. And as I'm coming from Germany, it's not surprisingly that I show you cases from Germany. It's a pleasure for me to being invited here and show you some results from research we've done in Germany, which dealt with in detail questions of the carbon storage. The context I can put over. Holger already told you the numbers enough. I would just switch to the life cycle of a building. And as you all know, we do have certain standards for life cycle assessment in the building sector. And we do know that all the environmental impacts in the built environment occur in all stages of a life cycle. So, as the standards in Europe say to us, we do have various stages: the production stage, the use stage, and the end of life stage. And up to now, also as Holger already told you, we maximized energy efficiency in the use stage. This is kind of where we started from, where we achieved quite many things. Now I think it's the turn to shift the focus on the whole life cycle. So first of all, the energy consumption of a building is the main important issue we have to deal with. But having reached to a certain amount, at least in the standards and according to for new buildings, nearly zero energy buildings, we should think about what else and where else can we reduce environmental impacts. And here I do think the whole life cycle is the important issue, which means we should think about the materials, the products we build our buildings with. Also, how about maintenance, repair of buildings, and then complying with the whole life cycle? What's about demolition and recycling? Thinking about closing cycles, what can we do with recycled material in the end? To show you these results in some numbers, just a quick comparison. We do have on the right side an apartment building to a standard called in Germany the passive house standard, so nearly zero energy. And on the left side we have an apartment building to a standard about 10 years ago. And what you could see is the primary energy in the building in the life cycle for about 50 years. In gray you see the energy consumption in the use stage, like heating the building for about 50 years, and that's quite clear. In a passive house building you'll use much less energy for 50 years. And what you see in light green is the energy bound or used for building the houses. And in dark green, the energy used for replacing materials in a life cycle of 50 years. So what's obvious, in general, the primary energy use in 50 years is getting less in the passive house building, but we're also having a shift that the importance of the construction and maintenance of a building is getting much higher. So the better the energy standard of a building gets, the more the reduction potential is on the primary material side. So I think for the future, or from now on, we'll also not only have to think about the energy efficiency of the use stage, but we also have to think about which materials we use for building our new buildings or also renovating existing buildings. And as we have to use all potentials in our own countries, we'll have to really think about what else could we do, which materials can or should we use. This brings me to the main course of my lecture, the carbon storage in the built environment, because this could be one option to also or additionally have carbon reduction potential in use. So I want to be screened. In a couple of months, we started screening what possible options do we have. And here's what we found out up to now. One of the main options at the moment is storing carbon in timber construction using bio-based materials and wood. For that, we do have already standards showing us how the carbon in carbon storage is calculated for timber and bio-based materials. And we do, in the end of my lecture, I will show you one example. Holger already had a picture of that as well, which could be one option. Additional, we also do have the carbonization of concrete. For that as well, we do have standards how to calculate that a certain amount of CO2 can be reabsorbed over a certain time. This means that the carbonization of concrete normally is taken in use stage, so it's kind of a long process, and it's needs that the carbon is exposed, the concrete is exposed to air. As a next idea, we could think about bioplastics instead of fossil plastics. Here, it might be a shift, but I do think still we should think about the recycling, or we have to have the recycling in our bags as well because of all the environmental burdens. But we still have to think about how the closing life cycles, extremely important for bioplastics, should work. Then the next thing would be thinking about green roofs, green facades as additional impacts of carbon storage as well, which could be easily made. There is the possibility of soil organic carbon inside, or biochar, where we could use the carbon accumulating in soil and plants as a result of organic processes. And then, all these opportunities are in place right now, so we could just right away use them, introduce them in our planning processes, and try to build according with using some of these factors. Then we researched what else is there in research, what else could we do, and we found out, screening to all literature which is available, that there is possibilities elsewhere, but with the first research result already. We have direct air capturing. We found at least one paper saying that yes, we could use direct air capturing in the building sector, meaning that for air conditioning and ventilation systems that produce additional synthetic fuels from CO2 and could be used, for example, in office buildings, small residential units, or grocery stores. But I must admit, this is just first research, so it's not realistic to use it right now. We do still much more research on that, but it's a way for future reduction potential, which we should keep in case. And as well, we do have carbon capture and storage, or carbon capture and utilization papers. There's wide research in the place, but we could not find any transfer to the built environment yet. So we'll still need the whole discussion and research about carbon capture and storage getting involved with the built environment to be used for that as well. So as the main carbon storage in place right now is still the wood and bio-based building materials. I'll want to go into more detail for that, because also for that we did most research recently. And what I want to show to you is some research we did, which is now in Germany widely accepted and used for the politics from the different ministries. So why are biogenic carbon storage so important? There are 4 greenhouse gas relevant effects which are in connection with biogenic carbon storage. There's the carbon pool in the forest, the carbon pool in wood products, the material substitution, and the energetic substitution, which means that, going back to the life cycle of a building, carbon is stored in the forest by trees growing, then the wooden material is put in place in buildings where we start temporary carbon storage, which exists as long as the building exists, and in the end of the life is extracted again. So over the whole life cycle, the carbon storage is 0, but over the time span the buildings are in use, we do have this temporary carbon storage. And as we presume that buildings should exist at least 50 years or longer, it's probably a certain time which could be, the carbon storage could be used. The other thing which has an environmental effect of carbon storage is the material substitution, saying that instead of using materials with high carbon footprint, we use materials with lower carbon footprint. And for that we did research projects finding out how much the substitution potential from material side could be. For that we had a research project which is called Greenhouse Gas Timber Buildings, where we analyzed residential buildings and asked the question, how large would the influence of building with wood be on the climate protection on national level? So asking, we do have a timber rate for buildings which is probably much lower than you do have here in Finland. But if we would exceed that to a certain amount, would that help to achieve climate protection goals in Germany at all, or is it just not worth doing that? How did we do that? We worked together with the Thun Institute for Wood Research, mainly, who do the national calculation on climate change for the land use sector. And we calculated on building level, we calculated life cycle analysis, LCAs, with various buildings, and then transferred them on a national level. How did we do that? First of all, our life cycle analysis of building, we are comparative LCAs, so we compared wooden buildings with mineral buildings having the same functional equivalent. So both buildings do have to have the same energetic standards, both buildings have the same fire safety regulation, sound insulation and so on, which means that probably timber buildings are constructed completely different to mineral buildings, but they are, the important thing is the functional equivalent, one building is the same. We calculated them according to the European standards, EN 15978 and EN 15804 on product and building level. We calculated them with a database which is called the Ökobaudat in version 2016, which is the official German database for life cycle assessments, which we use, which is according to standards as well. And from that on, we calculated our substitution factors. What we did additionally is we gave all our data to a critical review panel, which went through the data, and the review panel was chaired by the former chairwoman of the TC 350, Frau Schminke, who was quite tough on how we did our calculations, how the functional units were. But we did that, and we are still doing it for new data as well, because I do think it's very important that the data which which we bring out and where we start to calculate with them in the political issues are right and are not in one or the other direction wrongly to implement it. So what we did is we showed the reduction potential from greenhouse gas emissions from a mineral building if it's replaced by a functional equivalent wooden building. What we did, we divided up the building in two parts. One part is the load-bearing structure, so if I'd replace a concrete or masonry structure by a timber structure, which then is truly a timber building. And the other thing is all additional elements like windows, doors, floors, facade are exchanged from mineral materials to wooden materials. This can apply to all buildings and is not only limited to timber buildings. I do think this is very important because the potential we could generate here is in times, or at least in Germany, probably bigger than only having timber buildings. So what I shortly can show you is the results. Results we divide up for single family buildings and apartments blocks. For apartments blocks, obviously, the reduction potential is smaller because the fire safety regulations and the material used for that is far bigger. What you could see here, there's a whole range. There's not only one substitution potential. It's a whole range dividing between 35 and 56% per square meter of gross external area. And if we put that together, more or less, for single family house, you see on the left side, there's a potential factor from 0.35 to 0.56, which means you can reduce the greenhouse gas emissions between 35 and 56% per square meter of an external area for a single family building, or between 9 or 48% per square meter for an apartment building. The substitution factor varies quite much because it depends how many parts you could really replace. So depending if, for example, the very low factor was a building where we had a roof which in the mineral version already was a timber construction, so we can't replace it, it still stays timber. And on the other hand, if a building which was meant right from the beginning to be an eco-friendly, zero-energy building could have a very high substitution factor because we try to replace as much as possible in material. On the right-hand side, you could see what the additional material could have as a substitution factor. And I do think this is very important or interesting as well. Although we build normal or mineral buildings, we can have an additional substitution potential by 10 to 20% using additional elements in timber construction rather than normal construction, which is quite important, for example, if we have hybrid buildings, having a concrete structure and all the additional elements, or at least the outer walls in timber frame construction, for example. So what I already told you, the substitution potential could be named for the residential sector. We at the moment are calculating substitution potential for the non-residential areas like halls, schools, office blocks, and so on, where we do get kind of similar substitution factors, but they still have to go through the review process. Additional, what these buildings do have, they have a carbon storage which is between 100 and 200 kilograms CO2 per square meter of gross external area. And if you sum that up, it sums up quite a lot. So this is the numbers on building level. If we then go further on the national level, we have changing patterns of wood consumption that can result in significant sink or source effects, depending, hopefully, sink effects. Since 2013, the carbon storage effect in wood products is also included in the national accountings through the rules of the Kyoto Protocol. So this means that in Germany at the moment we have a carbon storage in wood material of 3 million tons of CO2. And the question is that could be enlarged by using more timber buildings. So what did we do? First of all, together with the Thünen Institute, we screened all national statistics. We do have statistics on national building activity divided up by the main materials. We do have national production of semi-finished wood products statistics, and we do have a mass balance of our LCA calculation. We combined that to make a scenario for the actual state, and compared to that actual state, we made different scenarios where we increased the wood consumption, saying until 2030 our wood consumption would rise to 50% by single-family houses and about 15% of apartment blocks, and by that we could calculate the estimate of biogenic carbon budget and material substitution. And this is what I want to show you right now. What we calculated these national statistics in the tool from the Thünen Institute, which is the Wood Carbon Monitor. My colleague from the Thünen Institute, Sebastian Rüther, is doing the calculations for the national statistics as well. So he has introduced this calculator. What you see here on the top chart is in brown, it's the amount of timber buildings, and all the different blue patterns are the mineral buildings. If we, in the middle, you have a state until 2015, and then we calculated until 2030 in the end, where we said we increase the rate of timber buildings from 15 to 50% of single-family houses, and from 1.5% right now in Germany for apartment buildings to 15%, which means that the amount of timber used in the building sector will rise quite a bit. What you see in the next chart in the middle is the amount of carbon stored in these buildings. You see in the brown statistics the biogenic carbon stored in the timber buildings, and the upper one is the carbon stored in the mineral buildings, so it's all the additional material which also can store carbon as well. So what was the result? The result was that till 2030, only for the residential part, we could generate a reduction potential by 1.43 million tons of CO2 per year, which is, for the German context, is quite a lot. And we can do that with all technologies which are developed right now, so we don't need new technologies to be developed. What we do need is an increase of raw material, wooden material, by 1.5 million cubic meter of harvested wood, which is around 4% of the national harvested material in Germany. So discussing these results with the German forest sector, we all say we do have enough trees in our forests in Germany so that we can easily do that till 2050. Right after that, we probably have to think about new technologies. But until there, it's probably quite a lot of time to think about this. So going from that, we'll probably exceed our calculations for the non-residential sector this year or next year. Well, just what are the conclusions out of that? First of all, I do think we need very energy efficient buildings where the energy we do need must or should come from renewable energy resources. We should construct our buildings, new buildings, and renovate our buildings as good as possible. Then I do think we have to develop all materials, wooden and non-wooden material, it doesn't matter, with reduced greenhouse gas emissions. And I do think we'll have to have a whole lot of more effort put in reducing greenhouse gas emissions for the construction sector for all materials. It's not to one or the other materials, but all of materials need more to reduce greenhouse gas emissions more. And then what we could do is building more buildings with wood and bio-based materials, having in mind, at least in Germany, all these buildings we do at the moment do have concrete basements, concrete elevator shafts, concrete staircases for fire safety regulations, and in parts even the ground floor is in concrete as well. So combining different material choices is probably the state of the art we should go forward. And additional, think about landscaping sites, roofs, facades, greenery, we should include on that. To get that in place, I do think we need specific values for maximum CO2 emissions over a square meter over the life cycle of a building, or on the other hand, have a maximum carbon or a minimum carbon storage per square meter of a building, which should all our new buildings reach. This is something I do think we need to get in place, and to show you that this probably is possible. You see on the left-hand side, this is the image Holger already showed you, but this building is already in place by now. I was in charge advising the city of Munich, trying to reach a energy efficient and environmental friendly site development. The whole neighborhood is about 600 flats with 10 different architects working in place, and the whole site is mainly social housing. It's called the Prinz Eugen Park in Munich, which stores right now 13,000 tons of CO2. How did we reach that? We combined, or we implemented values for carbon storage, which were then implemented in the selling procedure of the building plots. So all architects and building owners had to achieve these values, which meant that at least they had to build hybrid buildings, having an outer wall in timber frame construction, up to building with mainly in wood, which still means we have one building which is a passive house building, having even done the elevator shaft in CLT and so on, but even this building only has a value of about 13% of timber in mass balance. The rest are other materials like concrete, gypsum board and so on. So even there, I do think there's a potential which we could still use, but this is at the moment in Germany the neighborhood development which goes the furthest in saying, yes, we do have specific values which we apply to building sites, and this would help us to achieve reaching reduction goals in climate change debate. And I do think, as we started this project in 2014, this year it's getting ready right now, and then now it starts in Germany. The whole discussion about different site owners and cities are coming up to me and other partners and saying, how could we do that as well? How could we allocate these values? I think this could be a possibility which seems to work. Even for architects, it seems to work to construct a whole range of different buildings and different architects being able to work with that. So thank you very much.
Yes, thank you, Professor Hafner. We have had a few questions here, actually quite a lot, and we are fortunate enough that we have a time in our schedule, so I can have a few questions for you. This is something that is also really widely discussed in public in Finland too, about the usage of wood and wood construction, and do we have enough forests? So We have one question about that. Have you studied about the influence of decrease in carbon sink in forest caused by increased use of timber? And what is your opinion on that?
I'm an architect. I'm not in the forestry, but being member of the Forest Advisory Board for the Ministry of Forestry, I do know about these discussions. We do discuss that, but in Germany it's kind of a widely known consensus at the moment between Ministry of Forestry, the Ministry of Environment and the Building Ministry, but an increase of timber building would help us for the next 20, 30 years. So we included all these discussions. There's probably a whole lot of more discussions about the use on forests and timber buildings.
Yes. Then another one, when is Germany going to include embedded emissions in the regulation?
Very good question. We wanted the ministry to include it right now. But for now, I guess for next couple of years, we haven't got the power to get it through. We are still working with various parties to get the whole life cycle of embedded energy in the energy calculations.
Yes.
And I do think we'll get there, I don't know when, hopefully in the next couple of years. It's a different question because there's so many different aspects to use. I think we'll try to, first of all, get it by additional grants, and hopefully by then, in, I don't know, 25 or depends on the political agenda, we'll hopefully get the whole life cycle in there.
In Finland, we have a wood promoting program here for the government. Do you have that in Germany?
Not yet. We don't have that yet. For the case in Munich, where the pictures came from, we had that, which meant we included per kilogram carbon you stored in a building, you get a certain amount of euros or less than €1. We'll try to get that for whole Germany, but it's quite difficult to get it right in place.
Yeah, thank you so much. We have also a small gift for you. Here you go. Thank you.
Okay, so next we will be hearing from our minister, but while she's on her way, I would actually like to take the opportunity and interview both professors. So if you can please come here. You are most likely not fully aware of where Finland is going in terms of regulations for the low-carbon construction, so I think it's a perfect opportunity to reflect and have your first impressions. So we are about to go into norms of setting these carbon levels or maximum budgets for buildings in less than 5 years. So from your perspective, how does that sound? You have been following the development in different European countries, so if one country is aiming towards these fixed levels, would you feel that that's a good way to go, or is that going to freeze all the creativity in the sector? Any reflections on that?
I do, as you probably could guess, I do think it's a very good idea. I would like that Germany does the same, and I do not think that this freezes the debate about how to construct. As I went through my project here in Munich, I analyzed, I'm still analyzing the life cycles of these 10 different architectural designs. And I must say, although they all had the same specific numbers to reach at, the design and the construction was completely different. So I do not think that it freezes anyhow the creativity at all.
No, I fully agree, actually. I think it's absolutely necessary. This is what I tried to show. we need to be brave. We need to do things differently than we have done so far. And we need these values. There is no way around, actually. And I would like to encourage Finland and also the other member states to work on pilots, build it, show it like Annette did, actually. We need these values, but we need also accept a little bit that we fail and that we test. And this is also what I miss a little bit. Be brave enough, and this is really research. We always should show that everything works. No, we have also to have the opportunity to fail. And I think this is absolutely important. Of course, with the regulation, you cannot do it. But we have the same discussion with Boverket in Sweden. So we need to take these numbers into consideration to make this happen. And I have high hopes that especially the countries that have a lot of forests go ahead.
But then there is the question of, and this is a very difficult question, at least, because it comes to your personal comfort zone. Professor Waldman, you were talking about comfort zones. So do you foresee that anywhere in the future we would have to consider that how much can we afford to build per capita? Or is this something that is politically so difficult question that it never comes to the debate?
Would you like to start? Should I? I think that we are. Can we afford? Means are we brave enough, or are we willing to do so? And I think we need to. We need to really reconsider how we run our economy, how we run our societies today, to make a change happen. So of course we have also to talk about sufficiency. Yeah, it's not only about 50 square meters per capita. So we have to talk about this, and there are many, many other countries where we already talk about a budget, a carbon budget, a resource budget, wherever per person. So I think we have to go in this direction. It's about efficiency, but also we have to touch upon sufficiency. I know it's not very sexy, but I think this is absolutely necessary.
Yeah, and we probably have to combine the debate about efficiency, sufficiency, closing life cycles, thinking about all these discussions together, and then be brave enough to do new things.
Okay, thank you very much for your presentations, and I would just remind the audience that after Minister's opening remarks there will be a coffee break, and you can have a chance of discussing with the professors during that coffee break, so please do take that chance. So thank you very much again.
Thanks, Martin.
Thank you.